Okay, folks, have a bizarre problem for you with an incalculable number. In other words, it's not like this is 2 cubed and you can write it down as 8 or 5 to the third and you can write it down as 125. This is a number you cannot write down. It's unpronounceable. It's beyond comprehension of its magnitude. But we're trying to show that this number can be expressed as the sum of 3 distinct powers of 5. And that just means like 2 to the 5th, just like I just said, okay? We want to show that it can be expressed as the sum of 3 distinct powers, and they'll be too big also to say or really write down, but we can represent it in a fashion that's fairly helpful. And I learned about this problem idea from Titu Andreescu's prep materials way back when he was, I guess, coach of the IMO team, way back in 2002. Now let's get into this, and there's a few ideas. Listing fifth powers is a very, very good idea to begin with, right? And what I'll write down also, I didn't write down 7 to the 5th, but it's pretty apparent that 7 to the 5th is too large, okay? It's 4 digits, okay? This is 4 digits, and that's not hard to believe. It's 4 digits, so we don't have too many fifth powers to worry about, so to speak, okay? This is 4 digits, forget what it is, but it's bigger than 10,000, okay? Now, so you got these other powers of 5 written here conveniently, so let's see how we might proceed here. This is an interesting first step, okay? See how I have 8050 right here? Okay, we have 8050, which is a multiple of 5, okay, which turns out to be very important. And then we just have our laws of exponents going on here. So this looks kind of strange because the numbers are so big, but it's just the simple laws of exponents. All right. Now right here, 8050, the benefit of writing that way is you get this nice convenient representation exponentially, because 5 times 1610 is 8050, right? So we already have a fifth power right here. Okay, we already have a fifth power right here. Okay, but hopefully you're motivated at this point to know that this problem is not going to work unless you can write 8051 as the sum of fifth powers. Okay, and I won't bore you with all the details, but you can. It's equal to 2 to the 5th plus 3 to the 5th plus 6 to the 5th. Okay, it's not quite as hard as it looks. You can find it pretty quickly. But 2 to the 5th is 32, 3 to the 5th is 243, and then 6 to the 5th is this number here, 7,776. You take that sum and you get 3 fifth powers. So you see you have a bunch of fifth powers juxtaposed. Now I could right now say we're done. You know, I mean, right now I could say finished, all right? And I'd almost prefer to do it because it takes a lot to write all this down. But using that property of, in fact, I may just do that and maybe you guys will trust me. Notice that you could think of this as what, a to the 5th right here. Hopefully you guys will tolerate this. A to the 5th plus c to the 5th. Or let's call it b, okay? Let's preserve the alphabetic character of this. Okay, so you got, that's horrible, but that's a b to the 5th. And this is c to the 5th. Okay, and we'll call this object d to the 5th power. And you guys can see what I'm doing right here. What this does is when you expand this out, you get ad to the 5th. Yeah, and this gets the point across without me having to do too much writing, okay? AD to the 5th. And the numbers are unimaginably large. What did I say this was? B? Okay, so this is BD to the 5th. C right here, plus CD to the 5th. And that completes the proof. All right. So I thought that's kind of neat how that worked out. They are distinct, clearly. And this is the answer with these assignments here. Do I got it right? I guess A would be, yeah, A to the 5th, D to, yeah, this is all good. This is all good, right? We got an A to the 5th term here. Yeah, B to the 5th. And then properties of exponents says that you can do this. It's really governed by the commutative property, I guess, right? Or something like that, whatever. But anyway, this is true, and that finishes the proof, folks. I liked it quite a bit because at first glance, this problem looks impossible. I mean, you're going, what? You know, the temptation is, how do you compute that? You know, but you never have to actually compute it. You just have to notice it admits this particular form where 8051 itself was contrived to be the sum of 3 fifth powers. Okay, and of course, when you multiply it out against a much larger fifth power, you get the sum of 3 fifth powers. Okay, folks, that is all. Thank you for viewing.